አሁን ይላል so then yeah በጣም አሪፍ እዚህ ጋር ባለው ነው so model is a conjugate functions አለ so basically ቅድመ እንዳየነው the parameters ማለት so theta on theta ብዙ ጊዜ አንግል ነው ፊዚክስ ማትስ ላይ እዚህ ኤምኤል እዚህ ኮርስ ላይ ደግሞ ቴታን እንደ ፓራሜትር ነው ፓራሜትር ቅድም ብለናል ፓራሜትር weight how important residual so the other word residual so let me write you the terms I will share this file ራሱን ስለዚህ ቆይ ስላይድስ እንትን ላይ ነበር 12 አይደል so እዚህ ጋር መጣችሁ የሌክቸር 1 ኮድን I think I shared it last time ግን with the new comments አሁን ሼር አድርገዋለሁ እና slide 12 ጋር ስትመጡ I will add some notes እዚህ ጋር ለምሳሌ notes ብዬ አንደኛ important term parameter okay these are the weights of the input features how important well let me define with let me start with features feature what's a feature a feature is an input okay an input information okay an input when information about our task ለምሳሌ አሁን ድመት ከሆነ it could be an image it's like the እያንዳንዱ ፒክሰል ኢሜጁ ላይ ያሉት ነገሮች እንዳለ ፊቸር ናቸው okay then ያንን ኢሜጅ ወስደን ኢንፎርሜሽኖቹን ሁሉም ኢንፎርሜሽን ኢኳሊ ኢምፖርታንት አይደለም አይደል ለምሳሌ የድመት ኢሜጅ ከሆነ ዙሪያ ባክግራውንድ ላይ ያለው like መሬቱ ሳሩ ምናምን it's not important አይደል መሀል ላይ ያለው ኢሜጅ ደግሞ it's important so ያንን ዌይት የምናደርግበት like ዌይት ማለት መመዘን ማለት ነው not ክብደት መመዘንበት መንገድ like different value ትልቅ ቫልዩ ካለው more important ነው ማለት ነው so ያ እንዴት ዌይት የምናደርግ ፓራሜትር ነው ቅድም ያየናቸው ለምሳሌ 2 እና -1 2x1 አሁን x2 ሲሆን 2x1 ማለት x1 በጣም ኢምፖርታንት ነው ማለት አይደል like twice ነው ቫልዩ የምናደርገው -x2 ደግሞ ማይነስ ደግሞ ማለት almost negative effect ነው ያለው ማለት ነው so like parameter tells you how important how so yeah wait how important each feature is then the other term was residual ማለት ደግሞ ኤግዛም ማን ነበር ይመስለኝ ያ ሚካኤል so ምን አለ ቅድም ፖይንቶቹን አፕሮክሲሜት እናደርጋለን ከላይን like if we're approximating points with a line ምን እናደርጋለን we choose the line that has the least distance so እያንዳንዱ ዲስታንስ ቅድም ስንል ይሄ እያንዳንዱ ዲስታንስ ከፖይንቶቹ ያለው ዲስታንስ ማለት ነው ይሄ ዲስታንስ we call it residual like residual ማለት like ቀሪ ማለት ነው የቀረ ነገር ነው so ምን ያህል ይቀረዋል ነው so the distance this one the difference ከዚህ ያለው distance it's called the residual so እነዚህን terms አስታውሱ እዚህ ጋር ነበር so the distance or difference between the prediction what we predict line ማለት and the actual the actual final like የምንፈልገው የነበረው ነጥብና ያገኘነው prediction ማለት ያለው ዲፈረንስ ነው I think ዳግመን ስንሄድ you will get በጣም more የገባችሁ ይላል so I should be on slide 12 then so I'm sorry yeah I think already we saw it so if we have x sorry 2 times 1 yeah so like there is another library she like numpy kanala numpy it's just a library way already it's a code no we just use it so numpy np np those will there are already many functions you can just use them all look in the zone ነገሮችን ለመሳል python ላይ there is a python library called plot just remember it as plot it's fine and now ይሄን ደግሞ ኢንፑት ስናደርገው we call it plt it stands for plot np ደግሞ stands for number so መታችሁ እዚህ ጋር ማለት ነው if you give this library a set of points it plots them so if you give it ለምሳሌ 2,1 it just dots 2,1 in the coordinate space ከዛ ደግሞ ይሄ ማለት ደግሞ መሰላችሁ just don't worry about this plot like ለሁላችሁ like a plotting code it's not about machine learning it's just visualization ነውና ካልገባችሁ it's fine just ግን ለምሳሌ የምንጠቀምበት ነው ግን ይሄ it samples points actually. It samples 100 points between 0 and 5. ከዛ ይሄ ኤክስ ፕሎት ነው like numpy array ነው የሚሆነው numpy vector ነው የሚሆነው ከዛ ይሄ ኤክስ አክሲስ ነው የመጀመሪያው ኤክስ አክሲስ ነው ሁለተኛው ዋይ አክሲስ ነው so ኤክስ አክሲስ እና ዋይ አክሲስ the same ሲሆን that's basically the function y equals to x አይደል so we see this green one no blue one I guess okay basically blue it's y equals to x these are the different functions we just plot them now we can represent this as a dot product blanket given x right like given a single point a single line one it's fine it's just a single multiplication now we can just use this one sorry two times can if it's multiple dimensional like two dimensional input ኖረን output one ቢሆን ለምሳሌ ቅድም እንዳየነው ሁለት x ኖረን x1 x2 ኖረን ሶስተኛ ከሆነ ፕሪዲክት የምናደርገው then in that case ምንድነው የምንጠቀመው instead of just multiplication with a number ሁለት ስላለን it's a vector then it's dot product አይደል so basically vector dot product ቅድም vector dot product ኖት ጋር ጻፍላችሁ መሰለኝ slide 12 it's important በጣም important idea we use vector dot product which is this to represent a linear function okay okay nice ከዛ so we plot lines like this ከዛ እዚህ ጋር እንጣና ነው so ኤረር ማለት ነው አሁን ቅድም ብለናል አንድ ነገር አፕሮክሲሜት ካደረግን በኋላ እንዴት ነው ምን ያህል አሪፍ ሰርተናል የሚለው የምናየው like ቅድም ሬሲዲዩ ብለናል so ሬሲዲዩ ዳይሬክትሊ አንጠቀመው ምክንያቱም it could be negative እና positive so ግራ ያጋባል ስላችሁ let me explain so let's say አሁን we had three predictors like again ሶስት independently predict ያደርጉልን ሞዴሎች አሉ ብለን እናስብ okay we have three predictors and now አላማችን it was to predict 5 okay then which one should we use ከሶስቱ ሞዴሎች ለምሳሌ the first one predicted 2 second one predicted 4 and third one is 5 it's በጣም easier we should just use like the last one why it's 5 then mathematically how do you represent it like I mean that's how I told memorize it's easier then how do you say choose the last one well how do on the መንገድ እንዴት ነው you know about do you know about index or indices it's basically how we sorry easy predictions the index are 0 1 5 and 0 stands for the first one right 1 stands for the second one like if you learned about lists you know this so አሁን መመለስ የምንፈልገው ምንድነው የትኛው ኢንዴክስ ትክክለኛው መልስ እንደሆነ ነው or የትኛው ኢንዴክስ የተሻለ መልስ እንደሆነ ነው so ምንድነው እናደርገው ideally like we wanted to predict ታርጌታችን ምን ነበር እዚህ ጋር it was 5 አይደል slide 13 so our target was yeah we're talking about loss on how do we compute the mistake now so our target was 5 and now our predictions are ሶስት ሞዴሎች ሶስት ነበሩ አንዱ ሁለት አለ አንዱ አራት አለ አንዱ አምስት አለ how do we compute the distance basically our error is the distance to make it more clear the residue is equal to it's going to be just predictions minus 5 actually let me just uncomment the others now so አሁን እዚህ ጋር መጣችሁ ማለት residue ብታውት you just print it how different is it from the target model the line 5 that is just ይሄኛው -3 -1 0 ከዛ አሁን ግን ማወቅ የምንፈልገው ዲስታንሱ ነው አይደል like how far is it so we square it like it's basically distance just difference in sound distance because in both directions ማለት ነው ኔጌቲቭም ቢሆን ፖዚቲቭም ቢሆን ትልቅ ዲስታንስ ካለው it's bad አይደል so we just want to say it's just a mistake how much is the mistake so just everything should be positive perfect case like what's the error or what's the mistake like what's the mistake in perfect or other arif case like no one are you guys following me we have predictions I don't know and we have a target, ideally ትክክለኛው መልስ ማለት ነው. Now we want to compute the mistake or the distance to the correct output ማለት ነው. And now we first find just the subtraction, like the residue, then we square it. Lemon, because the mistake or the distance from the correct point is fully positive ነው መሆን አለበት. Lemon, because like በኋላ የምፈልገው ሚኒማይዝ ማድረግ ነው ይሄንን ሚስቴክ ሚኒማይዝ ግን ኔጌቲቭ ከሆነ ሚኒማይዝ ታርጉት there is no end አለ ሁሌ just keeps going to negative infinity. So we square it, then the minimum point becomes 0. So when we have the correct prediction, we have 0 error, right? Every time ከዛ ውጪ we have a positive error. So ሁሌ አላማችን ምንድነው ማሽን ለርኒንግ ላይ ብዙ ካያችሁ the learning objective ማለት like learn የምናደርግበት ፓራሜትራችንን የምንቀይርበት አላማው ዋና አላማው ምንድነው? It's to minimize the error. Actually, we always have positive error or 0 error. Perfect scenario ላይ ከዛ we minimize the error. Actually, I hope you understand the part. It's not too complicated, right? ከዛ yeah, basically we had the predictions -5 አድርገን እዚህ ጋር we get -3 1 0, then we squared the errors. Now the errors are 9 1 0. A squared ይደረጋል -3 9 a 1, of course you know this. Then the average error we take. Sorry, what's the average error? We just compute. No, sorry. What is which one should we choose number? It's all the index. So the best index. So if I print the best index, I get 2. Okay. Why? This is 2. So argument. ይሄኛው ጠቃሚ ፈንክሽን ነው። እሺ አሁን ኖት ጋር ልጻፈው እዚህ ጋር ጽፈዋል። So every slide number ሲጀምር ማለት ነው ከስር መጥቼ እንደዚህ you'll see something እንትን እዚህ ጋር ኖትስ የሚል ኮድ ላይን ኖትስ የሚል ታያላችሁ። ሶ እዚህ ጋር የምንጽፈው ምንድነው ምን ብለህ ነው ኢምፖርታንት ነገር argument numpy does argument. Okay, it takes a vector as well. It returns the index of the minimum element. So እኛ የምንፈልገው the minimum error ያለው ነው። so እንደምናልኳችሁ ሞዴሎች ብዙ ጊዜ they have positive error, like you wouldn't find easily ማለት ነው. Like you wouldn't find a perfect model that has 0 mistake. Then how do we find the best one? We just find the minimum error now, we return that one. Okay, so index one ማለት so ይሄኛው ሞዴል ማለት like ሁለተኛው ሞዴል ማለት ነው። እዚህ ጋር ታዲያ this is the zeros, this is the first one, this is the second one. So we pass argument ላይ errors okay, this one. Quick question ቶሎ መልሱልኝ ቻት ላይ አሁን what is np.argument? Okay, let me just create a picture. np.array something that got follow ከዛ what is np.argument a actually 0 8 minus 2 7 6. What's the answer? Yes, I ain't kind of true. I'm disappointed more. Can't leave one you are. What's the answer? In Ransario. Is she? Oh, that's nice. Argument guys, it returns the index of the minimum element. So remember that. So A is this. What's the minimum element? Then what's the index? Oh. Okay. I think you missed the -2 guys. What's the minimum element? It's -2, correct? I mean 0 8 -2 7 6 7. What's the minimum element? It's -2. No, that's the minimum element. Argument does not return the minimum element. It returns the index of the minimum element. Okay, so it doesn't return the minimum element, it returns the index. What's the index of -2? Nice. Yes, it's 2. So it should be 2. Okay, I really like የመልሳችሁ ሁሉ አሪፍ ነው። እሺ ኢንተራክሽናችሁን ነው የምፈልገው እንድትመልሱ ነው የምፈልገው። እሺ that's the main idea again. No, so now let's say there are different predictions አለ so like error ማለት ነው። ቅድም ኤረር ስንጽፍ ምን ብያለሁ አስታውሱ? it's squared አለ then like we find the difference then squared, right? So we get the predictions. Okay, look at this better. Like look at the mouse here. We get the predictions, then we subtract the ideal or target value, then we square it. That is a quadratic function. Alright? It's a quadratic function. If you have learned it, it's fine. This is like middle. If it's apart, it is convex. Alright? You don't have to know what convex means. It means like one idea, there is one minimum value. Okay? When you have an error like this distance question አድርገው በጣም አሪፍ ቤኔፊቱ መሰላችሁ? we have ልክ እንደዚህ upward የሆነ ሳህን አለ ቦል የሆነ ኩባያ ይመስል ነገር አለ እና there is one minimum point. That's a very important property እዚህ ጋር። so what's the minimum point እዚህ ጋር? like minimum እናገኘው መቼ ነው? when the model is perfect, when the error is zero. ከዛ ውጪ ሁሌ ፖዚቲቭ ኤረር አለ እና it's both way ነው like በኔጌቲቭ ሳይድም በፖዚቲቭ ሳይድም ያ ነገር ከምንፈልገው ፕሪዲክሽን እየራቀ ሲሄድ ኤረራችን እንደዚህ በስኩዌር እየጨመረ ይሄዳል። ኦኬ ሶ ምን ማለት ነው? if I have a model አሁን ቅድም ስናወራ ካላችሁ ማለት ነው we have a model is a set of possible functions አይደል? ለምሳሌ we're talking about linear models. Then in that case we have a set of linear functions እና ያ linear functions it could be represented by a single vector አይደል? so I have a single vector and now I have a way to compute how close it is. ከምፈልገው ነገር how close it is. It's this function. This is called the loss function, or you can just say error function, but it's the loss function. Now it tells you how much your error is. So if I take those parameters, it's just a single vector, if I can change them until I get the minimum error, not zero, because fully zero means if there is a perfect line. Usually there is no perfect line. So we find the minimum error. Then we just learn the model, guys. We just learned our first model. We just take a set of a vector, okay, and then for a given set of inputs, we find the set of the vector, the set of parameters, parameter weights, until we get the minimum error. Minimum it means we created the best possible line model. So in this case, let me study. We start with a random line, right? Then line one, we just like randomly we slightly shift it. Then we shift it. When we find the perfect line, when we find the perfect line, then we stop. The perfect line, the minimum error. That's learning basically. Learning knowledge. We have a model it's like the brain one. I'm wrong almost. Those are the parameters, the numbers. That creates a function, a line. Then we change that line, right? We adjust it so that we minimize this error. So now we have a model. We have a way to measure the error. It's how do we learn it? We don't know how to learn it. I mean, we have a model. We can tell it how wrong it is. Okay? How do we change the parameters in a direction that it would be less wrong? ይሄ ሞዴል ከመጀመሪያው ፖይንት የተሻለ ሞዴል እንዲሆን እንዴት ነው የምናስተምረው የሚለውን አሁን that's the next exciting part አይደል? So 13. So what do we do? A model is a family of functions. Training chooses the member whose predictions fit the observed example best. So if we have these black points, we try to find the line that best fits this black lines. Fit ማለት another term. Fit ማለት just አድርጎ ያንን line ያንን point set of points represent እንዲያደርግ መጣር ማለት that's fitting. So in machine learning you use like this fit to train it, to learn from the data. So yeah, training chooses the member who whose predictions fit the best, right? The observed examples best. So we find argmin ማለት ምንድነው? We find the minimum index አለ. So we try to minimize the loss. ቅድም ያየነው corrective function አለ. That's the loss. We try to minimize it by finding the best possible set of parameters. This is the core idea of machine learning. We have data, then we create a model. Usually you decide what your model is. Okay, we just, let's say our world is restricted to linear models. As in scenario, we can only work with linear, like lines. Then our model becomes a vector, a simple vector, because lines could be represented by a single vector. Then using that single vector, that's those parameters, we compute the loss. Then we don't have this jump, okay? By finding a direction to change those parameters so that the loss will be a little bit lower, we update the parameters, and then we just keep on changing the parameters slightly in a direction to reduce the loss, to reduce how wrong the model is. At the end, we will have a model that can predict those points very well. So that is a machine learning. The core idea: you have a data, you create a model, then you compute the loss, you update the model based on the loss, so that you can minimize the loss. I hope that's clear. And like human like example, you have Tamari Alachu, then you create an exam, like a way to quantify how wrong, like how well he understood it. So you give it some text, right? You teach it something, teach him something, teach her something. Then it could be an exam, out of 10 or out of 100. Then you have a loss, then you change his understanding so that he will perform better next time, and so on, until you have the best possible scenario. So that's machine learning at its core. So sit with this idea. Actually, this happens everywhere. Like any machine learning model, like you have a model, you have some form of data or some environment, then you have a loss function, and then you update the parameters. This happens for every machine learning model, like from any. Okay, let me not make a broad statement. Again, it happens most of the time, like, so that it's very important. Actually, remember this. Now, a matrix represents a linear function. So if you have a matrix A, okay, let's say its shape is m by d. Now the shape comes as you have to be familiar with shapes. So m by d ማለት m rows and d columns, don't forget. So if I give it a d point, like so, maybe next time possible corner we change to Zoom. Security መጠቀም ፈልጌ ነበር ግን Google Meet ላይ security መጠቀም አንችልም። so ምንድን ነው የሚመስላችሁ? let me wait one minute. And it's screen stuff. Like I have to write something as you got. I'm trying to write. Let's give me 5 minutes. Oh, nice. ይታያል ምስሉ ነገር? Yeah. Can you see it? Oh, you can't see it, አይደል? Shit.
አይታይም ብኔ ምናልባት ዘ ሆል ስክሪንን እንዳለ ስክሪን ሻርግና
let's see, stop sharing again. Coming. Oh, ይታያል አሁን? በጣም እሺ። ሶ ምን መሰላችሁ አሁን እዚህ ጋር we have this matrix አይደል? a ሼፑ ምንድነው? m by d አይደል? so if I give it something that's shaped d by 1, I'm sorry, if I have a vector, this vector, okay, እንደዚህ አዲስ vector ቢኖር and if I have d elements, okay, this is called t. I have a new vector called t, actually, and I have a m by d. What's the shape of a times t? A shape m by d, m by d. A ደግሞ d by 1. So what do I have? ቻትሌት A is M by D and T is G by 1 ሼፓቸው and when I multiply A by T what do I get? በጣም አሪፍ እሺ yes yes nice ሞዝ ተወሰነ nice ቤትልኝ ይፈታ በጣም አሪፍ so we get ምን M by 1 so this is like it's called a transformation right? Basically d-dimensional የሆነ ነገር ወስደን you get m-dimensional output so ማትሪክሱ ማለት ነው it's a function that gives us that takes an input of size d and gives us output of size m so ለምሳሌ በሌላ ቋንቋ ማለት ነው አሁን our y የምንፈልገው y if it's a single number you can just make this m1 right no so m by 1 right? So like if we have m points ማለት ነው given this d-dimensional feature ለምሳሌ we have m pictures total m different pictures okay and another picture let's say they have d pixels you hear like 70 megapixel just change it to like a single number and then you have like higher photos with 70 megapixel you can make it to m by 1 at the end you can just take higher predictions at the end you can just get higher predictions it could be like 0 and 1 it could be just cut problem that's the simplest task so it's a function basically it's a function don't forget this so like this matrix A could be total pass is a function so whatever you give it whatever vector you give it okay A times X becomes transforming that into m-dimensional space where you just get a prediction by and then about everyone there is one property mathematical property it's a matrix is a linear function because if you pass like ሁለት ነገሮች can separate them like matrix products so like ማለት he don't think it's too complicated science ለበዛ it's not hard it just means like a times x plus y ማለት oh yes x plus y ማለት እዚህ ጋር it's the same as a times x plus a times y right? We can read separately so that's why it's called linear this is like a linear operator function the property so yes columns and yeah the row determines each output coordinate and the columns yeah basically the whole idea here is multiplying by a matrix is applying a function and then there are some important mathematical properties like this and as in study the machine collection then what actually happens when we do this product x w scenario there are different ways to understand this so there's like the row view and now there is a column view which every like depends on the exact application we're looking at so in part let me just explain it አሁንና በኋላ apply ስናደርገው ያንዳንዱን በደንብ ገልጸዋለሁ ግን just general view ልስጣችሁ so ማትሪክስ ስናባዛ ማለት ነው let's say a አለን እዚህ ጋር right then we have x we have multiplying a and x so let's say a is a b c d this and let's say x is x1 x2 so ስናባዛ ምንድን ነው ከስቶታችሁ መጀመሪያ we take this one right then ሁለቱን እናባዛቸዋለን right and we take this one we multiply this one so at the end we get the first one becomes ax1 አይደለ plus bx2 and so on so this kind of becomes እንደዛ so አንድ መንገድ ይሄን ለመረዳት ማለት ነው we can just think of this as x1 transpose right and it's a dot product between right it's a dot product between a b now x1 x2 right because look at this output መልሳችን ያገኘነው መልስ it's dot product in the so you can understand it as የመጀመሪያው ማትሪክስ ሮዎች ይሄዱ የሰከንድ ማትሪክስ ኮለምኖች ጋር ዶት ፕሮዳክት ያደረግን ነው that's one way to understand it okay this is called the row view like እነዚህን ሮው የሰራችሁ it's ዶት ፕሮዳክት ማለት ነው ሌላ another way to understand it ደግሞ ማለት ነው it's called the column view yeah just don't worry too much about this idea ይሄ አይዲያ ብቻውን በጣም ያን ያህል ለካላ ካልገባችሁ ጥሩ ነው ካልገባችሁ ግን don't worry too much about it በኋላ ደግሜ ኤክስፕሌን አድርገዋለሁ ሲያስፈልግ Another way to understand this ማለት ነው you can just think about just taking this ማለት ነው taking this and now scaling them separately ማለት AC የሚባል ወስደን እዚህ ጋር this vector በx1 እናባዘዋለን okay then we multiply x2 with BD and we get the same output at the end here it's just like interesting property so like depending on the data you're working with ማለት ነው understand ለማድረግ it's a በጣም አሪፍ ወይ ግን yeah deep down like if you know how matrix multiplication works you're setting yeah now the interesting part guys how do we do like the learning we have a loss how do we know where to go like how to change the parameters now let's revisit the idea of a derivative what is a derivative let's keep like አጻፉት ግን just answer it class what's a derivative ካልተማራችሁትም እዚህ ጋር መጠየቅ አሪፍ ነው so derivative ያልተማረ መጀመሪያ just raise your hands I see እሺ it's fine አሪፍነቱ ማለት ነው እኛ የምንጠቀመው ኮንሰፕት derivative the most basic one also you don't have to actually like learn the whole calculus ለዚህ ኮርስ ማለት ነው actually so derivative ማለት you can understand that as the slope basically literally it's like you know slope everyone knows slope so if you have like this line for example the slope is obvious just take the two lines the 2 points ziga and ziga right then find the vertical distance so you could divide the vertical distance over the horizontal distance basically በአንድ ስቴፕ ወደ ቀኝ ሲሄድ ምን ያህል ስቴፕ ወደ ላይ ካለው የሚለው ነው የሚሰራው that's the slope ግን for lines it's literally in the name probably if the slope is 2 this is probably y equals 2x right it's already in the function the slope is obvious now when the function is non-linear ለምሳሌ our loss function if you remember our loss function was quadratic now the slope is not the same everywhere obviously እዚህ ጋር it's በጣም ቀስ ብሎ ነው የሚሄደው right ወደ ቀኝ ሲሄድ ብዙ ወደ ላይ አይሄድም እዚህ ጋር ደግሞ ሲመጣ ትንሽ ወደ ቀኝ ሲሄድ it goes a lot ወደ ላይ so the slope ራሱ it's a function of where we are okay this now so let's define it in a different way okay the slope tells you no the derivative tells you like in one dimension it's easy to say just the slope a better way to understand this is the derivative predicts okay how much the function changes with respect to the input so again in them the linear function we just said it's always the same because depending on the input and the same amount of that's the slope okay then for a quadratic function like this okay if we have a quadratic function like this then the derivative itself is dependent on where we are how fast it changes or how much it changes so if I compute the slope ziga ማለት ነው ምን መሰላችሁ የሚሆነው it's going to be something like this slope like so it's like finding okay you find the slope at a single point or how much the function changes actually with respect to the input at a single point and one way like I don't know if you learned about limits again one way to let's approximate it no so if I have a curve like this as the derivative ከጠየቁኝ ማለት ነው it must be equal with there should be some line like this that's called the tangent ziga is the curve ziga slope should be similar with some line right? There should be some line that is doing like that has the same slope because we can define a line with the slope no so in this approximate እናደርገዋለን well ከዚች point ተነስተን okay let's call this x okay if we move some amount x plus delta x okay, how much does it change ከዚህ ከቤዝ ፖይንቱ ምን ያህል ይጨምራል so it becomes f of x plus delta x. Okay, እዚህ ጋር ለመጻፍ በደንብ አይታይም ብቻ we at this point to go on if x ነበር ወደ delta x ሄደን ምን ያህል ጨመረ የሚለውን we approximated assuming it's just a single, it's like a straight line ቢሆን ኖሮ እንዴት ይሆን ነበር የሚለውን assume አድርገን we approximated. Now ደግነቱ we don't have to do the derivative እዚህ ጋር like there are libraries ልክ እንደ numpy አይነት ሌላ library አለ it just does the gradient automatically, so don't worry about this. Just I want you to understand the concept actually, and the concept is like Abidan Dagim I think Dagim maybe like የተማሩ ሰዎች derivative understand it as the slope or how much the function changed with respect to the input. So when we come to the loss function, okay, our loss function is our loss function. Yeah, when we come to our loss function, okay, the input is the parameter. So it tells us, it tells us, okay, it tells us how much it changed based on our parameter. So basically it tells us what is indicated, parameter what is ከቀየር ነው loss goes up ይላል. Therefore if we change the parameter በዚህ በኩል the loss goes down. So it tells us which direction we should change our parameter so that our loss will be lower. So that's how we learn. If you don't get this, see, I'll try to hammer it again. Again, basically using the derivative, we find how sensitive the loss function is to the parameters of the current model. So now the loss is a single number. It's like a distance. So we find our prediction, we find the difference, and we find the norm. So the loss is a function of the parameter. So what we do is we differentiate ማለት find the derivative ማለት or find the slope. So we differentiate the loss with respect to the parameter. So the gradient is a vector that converts a small parameter displacement into like changing the loss, or basically parameter በሆነ ዳይሬክሽን ትንሽ ስንቀይረው ሎሱ ምን ያህል እንደሚጨምር ይነግረናል። ኦር በሌላ ቋንቋ ሎሱ በጣም እንዲቀንስ ኦር በጣም እንዲጨምር ፓራሜትሩን ወዴት ዳይሬክሽን like the maximum change እንዲኖር ፓራሜትሩን ወዴት መቀየር እንዳለብን ይነግረናል። ፓራሜትር ያልኳችሁ ቅድም አሁን 2x1 minus x2 ሲሆን like 2 እና -1 they were the parameters. So how to change them ማለት ነው. Yeah, if you don't get this, I'm sorry, like just take the time enough ትንሽ ስለ gradient ትንሽ ይሁንና revisit this lecture. እሺ እዚህ ጋር ያለውን part. So now the gradient ማለት ነው የሚነግረን is the direction of the most change. So if we just find the gradient እዚህ ጋር መተን ማለት ነው it's going to tell you እንደዚህ like the slope is ወደዚህ ነው የሚለን. Okay, so it tells you how to go like up the maximum direction. Again, loss like what do we want to do? Do we going to up? Do we want to go up or go down in terms of loss? Let's get comment this after loss ምን ማለት ነው? Okay, again like up is increase the loss. What is the loss? It is how far we are from the ideal, right? The target prediction. So we want to go towards the target prediction. So it should be down, right? Yeah, we want to go down. So yeah, Sarah or Sarah, I don't see your name. Yeah, Ejota Swali. You can reply. You can talk. Isamalim Singh? I think Sarun. Yeah. You raised your hand, Sarah. You can talk.
ቅድም እንትን እንዳደረኩ ነው ይቅርታ።
Okay. So the gradient tells us which directions to go up, and now we want to go down. So what should we do, guys? What should we follow? It's actually a simple trick. Abidan, what should we do? we want to go down. The parameter, the gradient tells us which way is up. So you don't want to try? Just guess. Yeah, but we want to go to the left. Good. Actually, in a real world law smart, we don't know which one is left, which one is right now. We just know the gradient, and the gradient tells us which way is up. So which way should we go? Negative of the gradient, right? It tells us to go this way. Because yeah, I mean, in this case, yeah, just go left. But we don't know which way is left. In this case, the gradient tells us to go right because right is up. Now we just do what? We follow the negative of the gradient. So negative of the gradient. Okay. So that is the trick. Like, so is it got negative style? Yeah. Okay, this sign is the gradient. On you're gonna see a lot of Greek signs again, it just means nothing. So A ማለት gradient ማለት, so the derivative with the slope. Okay, so we find the gradient of this, the loss, our loss with respect to the parameters. Okay, so which way we should go? Then we do this eta. This is, it's called the step size. It is how much step we should take. Like, I mean, yes, we found the gradient. The gradient tells us the direction, which way we should go. Then how much we should go, Milo? This is called hyperparameter. It is determined at the start. So let me just write it down. We are at slide 13, 14. Where am I? Oh, 19. Okay. I'll feed it next. So as you cannot last it large. So it is the gradient tells us which way is up. Okay, parameters, parameter, way, how important each feature is. It is learnable. Learnable ማለት we change it depending on the loss. Okay? There's another idea called hyperparameter. Okay, this is constant. Okay, we just choose a value and never change it during the training. So on the step size, so the theta is parameter. Okay. Okay, and eta is the step size. This is a hyperparameter, which means the step size, like, it's not something you have to worry about. We just usually just set it to 0.01 and it will be fine. I mean, most cases. Like, so then you find the gradient. Yeah, wait,
ኦኬ ሶ ቢኒ አይ ቲንክ 5 ሰዓት ሆኗል። የተጨማሪ ደቂቃ እንውሰድ ወይስ?
ኦኬ ሰዓት አለቀ አይደል? ሰዓት አለቀ አይደል?
ያ
ኦኬ በቃ አይ ቲንክ ኢትስ ፋይን ለዛሬ። ኦኬ
ሶ ተጨማሪ 10 ደቂቃ ልስጥና 10 ደቂቃ ልስጥና ሶ ዩ ካን ሰምራይዝም በዛ ጥያቄ መልስ ምንድን ነው? So you have additional 10 minutes.
Yeah. So okay, what do we do? Because guys, we take the parameter currently. Okay, we find the gradient, the direction we should go. Okay, then we negate it. We find negative and multiply by step size, a small step size. And now we change like parameter was there. We subtract, or basically we push it towards where we want to go. That's it. We want to go towards the negative of the gradient. Then small size number. I'll tell you the reason small. It's small step size. Sufficiently small. Then above 0. So yeah, basically until the gradient is 0, we just keep going. Now, for example, let's say this is a linear function. Okay, y is x transpose w. Those products, remember. Plus b. B is a bias. Like bias ማለት a function could be just y equals 2x1 minus x2. The parameters become 2 minus 1, and we can have a bias like +1 or plus something. The bias really doesn't matter. Like it becomes more part of the learning. So let's say y is x transpose w plus b. Okay, this basically means what? እያንዳንዱን w we do dot product አለ. So እያንዳንዱን x we multiply with each w and we add the bias. Okay, then this is like how we represent the matrix multiplication model. Those products, then our shape is n, right? So the parameters w and b are learned. Actually, please study this slide better. W and b, like the weights now, the weights and bias, and feature matrix x is the input, right? Y is the target, or like what we want to represent. Then okay, residual. Them basically these are the residuals. Okay, this distance is the residual. So yes, R is the prediction minus the actual. It's signed. So we square it. We square and find the loss. I think that's what I'm meant now. I hope it's not very too hard. Okay. So actually one important idea. Like don't get confused the bottom notation. ለምሳሌ R here. Let me add a note. So dot product with like a vector. If you have v1 mark, v1 dot with v1 is the same as the square of the norm. So basically norm of v1 square. I mean, if you really think about it, it's not confusing. Let's say on v1 is AB. Okay, what's the norm of v1? Norm of v1 is you already know it's square root of a square plus b square. Okay, what is v1 dot v1? Well, it's just a times a square plus b times b square. So this is the square of this. Of course, square root, like we just have to remove the square root. So that's one. So there is that thing called R transpose R. This means R dot R. This is like a matrix multiplication, right? If you remember, the first element transpose R again, matrix multiplication ማለት is the same as dot product. So R transpose R is R dot R, basically. This is the square of the norm of R. So basically, for a single number R, it's just the square. I'm explaining this because as you guys out, this might look confusing. Error stout. This is just a square model. Like for our case, a single number scenario, we're just squaring this. Okay, R square, the residual square. Our loss is the residual square. Hey, 1 over n basically average. It's like the average error. So if we have n points, we just do 1 over n, 1 over 2. That was exactly for internal derivative scenario. Square color, it becomes 2. So it really doesn't change anything. Like during the learning, like 1 over 2 still like under, like if the loss is lower in some direction, it just keeps being lower that direction. Half direction is going to be the same. So yeah. So the mean square error ማለት this ነው, like the norm of the residual, the square of the residual, 1 over n for average. So we're trying to minimize average. This is called the mean square error. Actually, very important. I mean, you'll see this a lot. So mean square error mean 1 over n, so it's a mean square error, or MSE by whatever it is, the average error. Average middle, it's residual square, the average residual square. So you just see 1 over n, you just see the norm of R. Okay, I hope this is very clear. Well, when we learn about like this modeling, what are we trying to do? Let me give you a broader idea. So what we're trying to learn is, like, let's say I give you some points, like this, and this. I give you like 8 points, 7 points. So my question is, like in the future, I want you to predict the points as well. If you got name it. So if you predict, let's say this line, you learn using this data. The data you use to learn is called the training data. Training data, right? Then in the real world, in real, like Sarano Wala, you might get a point like this, or here, like unobserved data in the future now. So that's called test data. So in the practice question and the exam question, so test is the exam, training is the So we're hopeful. We can prove it ball again. We are hopeful that by training on some of the data points, we can predict the test points. Okay? Because they're not the same. So how do we know it works well in the future? Well, if you have a lot of data in the training, then you can be sure the output is going to be pretty similar. The final is going to be pretty similar. So the loss is the average residual square sheet. So now we can compute each gradient per weight, but I'm not sure if this is like necessary. So I really want you to guys next class go በፊት ማለት ነው finish this slide sheet ከ30 ድረስ ከ24 ላይ እናቆም ነው like the lecture 1 slides ከ24 እስከ 32 just finish them on your own. It's going to be very confusing another part ላይ it's fine. Then next time like ያልገባችሁን part ብቻ ነው የምንሄደው because we have to cover more no, just ask ChatGPT ያልገባችሁን ነገር now take time with it and now I know it could be confusing, so just take your time with it, digest it, and we'll get back to it. Paul. And now, any questions? Any questions till page 24? And now, those of you who have already learned about derivatives, I think it's going to be understandable. Just go through it. Yeah, it might be challenging. Then just ask it around or online video. I'll get back to part discuss next time. Then please I'll get back to now taking count tomorrow most. Bamlakesh.
ቅድም ኤ ዶት ቢ ኢዝ ኢኳልስ ቱ ኤ ትራንስፖዝ ታይምስ ቢ ነው ብለህ ነበር እና እንዴት ነው እንደዛ ልክ ነው?
Oh. Yeah, zero. So they say v1 a comma b number like this is the vector v1. Okay. Now v1 dot v1 ከራሱ ጋር አገና ነው maybe እንቀይረው እንዴ I think it's fine. እንቀይረን ነው. So let's say v1 is a comma b, okay, and v2 is c comma d. Then what's the dot product? Bamlak. v1 dot v2 ምንድን ነው?
a times c plus b times d.
Bravo. Then what's on v1 shape like look at this as a matrix multiplication ካየው ማለት ነው okay ሁለቱም ሼፓቸው it's 2 by 1 okay as a vector ካሰብከው ማለት ነው like as a matrix ካሰብከው it's 2 by 1 or just what I want to say is as a matrix ካሰብከው ማለት ነው 2 by 1 2 by 1 and 2 by 1 then what's v1 transpose? v1 transpose is going to be a comma b. The shape is going to be 1 by 2, right? So if you multiply v1 dot t with v2, the shape is going to be min. Yeah, v1 transpose shape 1 by 2. Okay. Yeah, v2 shape 2 by 1. Then v1 dot t times v2 shape undino. Okay, it's fine. v1 dot t ሼፑ 1 by 2 ማለት ነው 1 by 2 የዚህኛው ፓርት ሼፑ 1 by 2 ነው የዚህኛው ሼፕ ደግሞ 2 by 1 right so 1 by 2 times 2 by 1 ምንድነው የሚሆነው ሼፑ
1 by 1
nice በጣም አሪፍ it's 1 by 1 it's just a single number ስካላር ነው so I mean it's scalar so ሼፑን አሁን ስናባዛ ማትሪክስ መልቲፕሊኬሽን ላይ ይሄንን like the first row ትወስድና ከዚህ first column ጋር ስታባዛው it's actually going to be a times c plus b times t so yes v so ይሄንን ላልኩት ለምንድን ነው it's just to say v1 dot v2 ማለት it is yes v1 dot transpose times v2 is it clear ወይስ
እሺ
I'll share this notebook now. Let's play maybe. I'll share it on the group. Any other questions? Nice. Yeah, feel free to ask any questions in the group sheet. Telegram name now. I'll get back to you now. Thank you for attending. Yeah, plenty of questions.
So, Bini, thank you very much. Steve Lachonum, by reaction. Thank you very much, Bini. Reaction in them, but reactor. Yeah, so thank you very much. ከሰዓትም ሴሽናችን ይቀጥላል ከናውል ጋር ሶ ምን ሰዓት እንደዚሁ በኦንላይን እንገናኛለን ማለት ነው። እንደምታውቀው ዛሬ ፐርሰን ሴሽናችን ኤቭሪቲንግ ኢዝ ኦንላይን ሶ 8 ሰዓት እንገናኛለን። ቢኒ ቴንክ ዩ ቬሪ ማች ኤንድ ቢኒን መጠየቅ የምትፈልጉትን ነገር ግሩፕ ላይ መጠየቅ ትችላላችሁ። ሶ እጅግ አድርገን እናመሰግናለን።
በጣም አመሰግናለሁ እንግዲህ